Today in the programme, space satellites the size of a shoebox. Why space exploration no longer requires huge investments and is available to individual groups of scientists. Today's Master of Crafts programme is about spacecrafts that will change the world. The new era of space exploration is today going full steam ahead after a very long hiatus. The first flights into outer space, launches of rockets to the moon, and the building of orbital space stations became possible due to the nuclear arms race. After the end of the Cold War, the governments of the US and the Soviet Union were no longer willing to spend colossal sums of money on the space exploration program. The last major project was the International Space Station. Fortunately, the technology made it easier and cheaper year after year to develop and produce the research apparatus, and the whole process evolved so quickly and to such an extent that in the mid-2000s, commercial companies for space exploration emerged on the market. Not only did the legendary entrepreneur Elon Musk plan to colonize Mars, he also created multiple-use launch vehicles. In 2017, an American TV channel host asked Musk which carrier rockets he considered to be the second best after those that he'd created. He immediately responded, the Zenit 2, made in Ukraine. These carrier rockets were developed and tested back in the 1980s at the Pivdeny machine-building plant in Dnipropetrovsk. So why, after 30 years, does Ukraine not have its own space exploration program? In truth, Ukraine has such a program. PhD in engineering Boris Razumakin and engineer Yevhen Kovalenko are space explorers. They are members of a team of Kiev Polytechnical Institute scientists which developed 2 world-class satellites, and at the moment they are at the low near-Earth orbit, sending signals to planet Earth. The CubeSat standard allows for quick and relatively inexpensive preparation of the satellite for launch in a container. We consider ourselves to be one of the universities that develops and creates the latest format of the CubeSat nanosatellite. According to space classification, the nanosatellite weighs no more than 10 kilograms. But this begs the question, is it possible to pack such a highly classified and beneficial product into such a small box? This satellite is one of the group of 50 satellites that take part in the national project QB50. So the idea is that the satellite flies in space. The transducer is in the front of the apparatus. What do we need it for? How do they put together nanosatellites? And what makes Ukrainian space developments absolutely unique? The main problem in launching a standard satellite lies in the fact that it is very expensive and a high-risk adventure. While there are not so many investors who are prepared to risk such a huge amount of capital in this project, this does not stop die-hard scientists from realizing their dreams. In 1999, professor at the Polytechnic University of California, Georgi Puk-Sari, and his colleague, Bob Twiggs, developed the CubeSat format. According to their idea, the satellites were to be very small in size, in the form of a cube, and could be launched into orbit at any time. The development of such kind of satellites took several years, and in 2003 the first set was successfully launched into orbit. And then these satellites were no longer built at large plants, but in small university labs. After that, even scientific startup projects emerged for the exploration of space.
We started with a very, very simple idea. Affordable access to space. Space should be for everyone. It shouldn't be just for, those which are the right stuff, or those which have enough of the green stuff to get up there, but it should be for everyone. You take advantage of all the cost-lowering mechanisms that is happening right here on Earth and find a way to leverage it into space.
Scientists from the Kiev Polytechnic Institute were invited to join the international program in 2009 at a conference at the Pivdeny Design Bureau, which created one of the best rockets in the world. By that time, the group, led by Boris Razumakin, already had the development of its own miniature satellite, but its configuration did not meet world standards. We made a decision to rebuild our satellite according to the CubeSat format. It took us some time because everything was in its initial stage. We changed it in a year, turned it into the standard 100 mm cube. It had a payload, and all the technology was taken from the Kiev Polytechnic Institute and Ukraine in general. In short, the first satellite developed here was based solely on Ukrainian technologies. Boris Razumakin worked all his life in the plant's heat and power division, and he ostensibly had nothing to do with outer space. But the local developments in particular allowed him and his team to solve one of the most serious problems, namely sharp temperature swings. The unique system of redistribution of heat was successfully implanted into the frame of the solar panels of the first satellite. The Ukrainian Polyaiton-1 was launched in 2014, along with 24 other CubeSat satellites. The results exceeded all expectations. There were 22 CubeSat satellites. According to the statement of the launch service company, only the Ukrainian satellite is still active. 3 years later, the Ukrainian CubeSat continues to send signals to Earth, and now anyone on the planet can catch them and say hello to the apparatus. Basically, this is the only thing that the first Ukrainian satellite can do, namely to inform people that everything is okay. For the scientists from KPI, it was just a touchstone, a prototype for the technological trial. They immediately started the work on the development of the second nano satellite, and now their task is to complete a very important international mission. How do they do it? The International CubeSat standard does not presuppose that each university will make absolutely unique satellites. The idea is unification. As a rule, scientists order details from the outside and simply assemble the apparatus in their laboratory. In the Ukrainian KPI, the lab technicians also design and build nanosatellites. Yevhen Kovalenko is one of the engineers chosen to participate in the project. He spent his time developing the second university satellite, Polyaiton-2. It is twice the size of the first satellite and has additional functions. Yevhen and his colleagues had to solve a number of technical problems in a non-trivial way. The first and most important part of any device is the power supply system, because without it, nothing works. We developed it ourselves, and we used very innovative batteries, lithium-ion, which earlier had mostly been used in electrical transport and airsoft. In space, we were among the first to use them, and it turned out to be very successful. Yevhen assures that such batteries can withstand a wide range of temperatures, from minus 20 degrees Celsius up to 60 degrees Celsius, and they last longer than lithium-ion batteries. The long life of the first satellite was guaranteed by solar panels on their own design. For the second device, they decided to order materials from a third-party manufacturer. This time, the engineers were more concerned about the functionality. This orientation system consists firstly of 3 coils that are integrated into the satellite's side walls and interact with the magnetic field of the Earth and thus rotate the satellite. In addition to that, somewhere in the middle of the satellite, there is a flywheel installed, which, by rotating itself, rotates the satellite in the opposite direction. The first cubic satellite could fly how it wanted and wherever it wanted, but for the second one, it is very important to properly locate it in orbit. The reason being that its mission is not just to send a signal about its condition, but to measure the composition of the upper strata of the atmosphere with the help of special sensors. Just as a whale grabs plankton into its mouth when it's moving, the sensor on the front of the satellite should capture atomic oxygen. In the space industry, this substance is known as a satellite killer. Atomic oxygen is the main factor in the degradation of the casings of space vehicles. Just imagine a spacecraft, no matter its size, needs to move at a speed of at least 8 kilometers per second in order not to leave its orbit. In order for you to understand this, such a satellite will cross Kiev in a matter of approximately 4 seconds. At this speed, individual oxygen atoms are converted into shells, which slowly but surely destroy the casing of the satellite and the satellite's solar panels. However, if you study the composition of the upper strata of the atmosphere in detail, you can map dangerous and safe areas. As such, the Ukrainian Polyaiton-2 became an important part of the international project QB50, the task of which is to chart such a map. What is critically important is that the satellite itself does not become a victim of any unforeseen accident. You cannot call up a man who flies into outer space in a rocket to come and repair this satellite. If something went totally haywire, the satellite is dead. Therefore, it is necessary to duplicate the systems and duplicate the sensors. In our case, if one of the sensors fails, the accuracy of positioning and data collection connection will deteriorate, but the satellite will continue to function as planned. The measurements are sent to the university's terrestrial radio station once a day. If the connection is interrupted even for a whole week, everything will be saved in the internal memory of the device and will be uploaded the next time you log in. Yevhen says that according to the power of the CPU and the amount of memory, the Polyitem 2 could be compared to a smartphone, although it weighs about 2 kilograms and costs not $100, but somewhere in the ballpark of $100,000. On the scale of the space industry, this sum is minuscule, but the Ukrainian university had to find sponsors for this project. One of them was the Ukrainian division of the US Boeing Corporation. The Ukrainian satellite was thoroughly tested in a thermos vacuum chamber and sent on a launch vehicle for the International Space Station. Thanks to the arrangements with NASA, universities are given a significant discount for the delivery of nanosatellites into space.
In space.
Good progress right down the middle of the corridor.
On May the 26th, 2017, 24 nanosatellites created in universities around the world, including the second Ukrainian apparatus, were successfully launched into orbit from the ISS with the help of a Japanese robotic manipulator. It has already made contact with Earth and is transmitting valuable measurement data. However, instead of celebrating success, Boris Razumakin and his team are already working on the next 3 devices. The third Ukrainian CubeSat will shoot the surface of the Earth in various spectra. Finally, the tasks of the rest are much more ambitious. The fourth project is called Biosat. We are ready to test the effect of microgravity on the growth of plant seeds. There will be a special cassette, a camera 80 by 80 millimeters in size, with soil and an atmosphere that allows plants to grow. A mini flower bed for 2 seeds, a video camera, as well as moisture, temperature and lighting sensors should fit in exactly the same box. The results of this study will help future colonists of the Moon and Mars. The task of the 5th prospective satellite, developed by Ukrainian engineers and rocket scientists, called Gravisat, is to solve one of the most serious problems of inhabitants of the planet. Due to the change in wavelengths from GPS receivers, Ukrainian scientists have proposed to analyze them, identify their gravitational component, and also to predict earthquakes, volcanic eruptions, and other natural disasters by analyzing the changes in gravity. So far, this is a theory that needs to be tested in practice, but it requires the International Space Program of nanosatellites to promote science without spending billions of dollars on expensive spacecraft. Ukrainian scientists have already proven that they can create unique nanosatellites and make a significant contribution to world science. These cubes are just the first bricks in the foundation of a new era of accessible space.